We're going to look at a modification of the simple random sample called stratified random sampling. Imagine you have a population like this here, and you're doing a study on hair. You've got a bunch of guys with hair, a bunch of girls with hair, and then a few bald folks. And we'll say for our sake that these are guys in this case. And you randomly pick people to be in your sample. Let's randomly pick this guy. Let's say our random number generator randomly picks this guy, and this person, and this person, and this person. So these are the 5 in our sample. If that happens, you can see that 2 out of the 5 people randomly ended up not having hair. And if you're doing a study on hair, my guess is their opinions are going to be pretty different than the people that do have hair. Let's back that up for a second. What if we took a different sample now? So we randomly pick 5 people. We might end up with no bald people in our sample. Well, that's not representative of the population either. Whenever you have small groups that likely have very different opinions than some of the other groups in a population, which often comes up, let's say, studying smaller religions or smaller racial minorities, you want to make sure that everyone is represented. The only way to do that is with a stratified random sample. Imagine that you have a school of 580 students and you want to take a sample of 40. But here's the thing, you don't want to just randomly pick 40 people out of the school. You want all grades to be appropriately represented. How do you ask the right number of people in each grade? How many should you ask in each grade? Let's look at our breakdown here of this particular high school. The 580 students, 120 of them are 9th graders. 150 are 10th graders, 130 in 11th, and 180 in 12th grade. And if you add these up, we have 580 students altogether. You can see that the 9th grade is actually a little bit smaller than all the other grades, and the 12th grade is a little bigger than all the other ones, and they're all a little bit different. To do this, we're going to use proportions. 120 over 580 is the fraction of the school that is 9th grade, 120 9th graders out of 580 total. And we're going to set that equal to some number of 9th graders in our sample out of 40 total students in our sample. So we have here the population, 120 9th graders in the population out of 580 in the population. And on the other side, how many 9th graders in our sample out of 40 students in our sample. Hopefully many of you remember back to the wonderful days of, let's say, 8th grade when some teacher beat proportions into your head. You always can use a quick little trick to cross multiply and divide. So by cross multiplying here, I'm actually going to just throw a little x in here so that we have a variable, but you can call it whatever you want. Cross multiply, you get 120 times 40, and that's going to be 4,800. That's equal to, cross multiply the other way, 580x. So we cross multiplied. You want to get x by itself, so what do you do to both sides? You divide it by that 580 so that x is alone. Some of you might be getting excited. This might be the first time in this course that a real math problem has actually come up. So these are going to cancel each other out. You're going to get x by itself. Over here, 4,800 divided by 580. We're going to use our calculator for that. Unless some of you can do that in your head. And we get 8.27. And since we're taking a sample of human beings, of people, 8.27 human beings is probably not going to work. So we're going to round this off to the nearest whole number. In this case, we're going to round it down, so we're going to get 8. So we're going to say how many 9th graders? X is going to be equal to 8. So 8 9th graders in the sample. Once you have those 8 9th graders, how do you choose them? we're going to go back and use our simple random sample when we do that. So just like before, we put all the names in the hat and randomly picked. This time we're going to only put the 9th graders in a hat and pick out 8 of them. So that's how we're going to choose our 8 9th graders. Then we repeat the process. We go to our 10th graders. First step is you set up your proportion. We have 150 10th graders out of 580 total students. That's, in this case, if you do the math, 10.34 10th graders in the sample out of 40 students in the sample. And because we have real human beings here, we're going to round that off, so we're going to round that down to 10. So we're going to pick 10 10th graders. Second step is to actually pick out those 10th graders. So we get a simple random sample, either drawing names out of a hat or using a random number generator and numbering a list of all the students. And we randomly select 10 people in an SRS of all the 10th graders. After that, we go back and we repeat. So we keep going to all the other options. So we do the 11th graders and we do the 12th graders. We figure out how many to put in our sample and then randomly pick them. Just a quick point on the name. The reason we call this a stratified random sample is because each one of these options here, 9th, 10th, 11th, and 12th grade, are called strata. So that's why we get the name stratified random sampling.